All right, these are the definitions of what we did last class. So at Kurno, we'll try to wrap up with properties, okay? And then the other part that's left. So do you guys remember the difference between the two graphs at the top? One of them gave you wavelength, the other one gave you your time period. Wave is it? Class report. Because water like says 4.55 hertz. What does that mean? 4.5 is not a good like right? Very good job. You guys got that diagram last class? You went with last class. Right, also we've seen particle movements, types of waves, and cathode ray oscilloscope. Phase difference. Yeah, phase difference. Phase difference is a new chapter, entirely separate. That's the most important topic that we have. Done? Sure. Okay. Right. So progressive wave এর মধ্যে হচ্ছে এই জিনিসটা আমি আগেতে বলে দিচ্ছি যে I won't go into details as much as we did in O levels, but we have this in A levels. Okay. Do you guys remember ripple tank? So ripple tank হচ্ছে যদি আবার করা যায়, it will be like a waste of class, I feel, because it's exactly as what you had in O levels, if not less. Okay. So do you guys remember there were those refraction diagrams where a wave would go from one medium to another medium, it will bend and reflection method, right? We have none of that. Okay. We just need to understand the production of wave and what affects the speed, what affects the amplitude, what affects the frequency. Okay. So ripple tank is a good way to learn this. Is it mandatory that we learn the ripple tank? Not necessarily, but it's something that they ask you. So I'll explain what I mean by that. So let's say you have a ripple tank here. And if you guys remember, ripple tank here design is that there's like water on this tray. And there used to be something, and you'll be helping me out with this. What is the thing that produced the wave? Yes, that generated the wave, but do you remember what actually produced the wave in the water? The machine. Machine parts বলতে পারবা? কে বলতে পারবা parts of the machine? Because the parts of the machine is important. Wooden block, plunger. Yes, correct. So the device that produces a wave is called a dipper. D-I-P-P-E-R. Dipper it's a piece of wood basically, okay? But the thing is, the dipper, right, is actually not consistent. I'll tell you what I mean by that. So what if I want to produce a wave that is flat waves? Flat waves, one of the plane waves, the waves like straight lines, right? In that case, we use this kind of a dipper. So you take a block, you move the block up and down, it creates disturbances in the water, and that's what produces the wave, right? But the dipper is actually not responsible for generating the wave frequency. ওটা কিসের সাথে related? Yeah, exactly. Okay, so এখানে গিয়ে you'd find that there's this object like a structure here. It's called a motor. A motor মধ্যে একটা knob থাকে, and by controlling the knob, you can control the frequency. It is exactly the same thing used in your fan, the regulator. So you can increase and decrease the speed. Okay, as you do this, what happens is this dipper here goes up and down, and as the dipper goes up and down, it produces waves here, right? Now waves গুলো দেখতে খুব particular. Let me show you what they look like. So if you look at the waves here, what kind of wave would be generated by this dipper? The dipper goes up and down, right? And the wave is moving forward. What do you call that wave? Dipper উপর নিচে যাচ্ছে and the wave is going forwards. So the motion of your dipper is perpendicular to the direction of wave propagation, right? What wave is this? Transverse, right? So you have a transverse wave that is generated here. But আমরা যখন দেখি, we notice there's something interesting going on here. We notice that we don't really see a transverse wave. We rather see a line. Do you remember what was the line called? Wavefront, right? And wavefront আমাদের এই syllabus একটু often দেখা যায়, so একটু বুঝাতে চাইছি তোমাকে. So what happens is if you draw a line from here to there, that is basically the top of the wave, right there. And যেটা হয়, just let me draw this. Right, so what you will be seeing is you'll be seeing a line at the top and a line at the bottom. Okay, bottom একটা actually line আসে না, shadow আসে একটা. So it looks something like this. Let me show you the entire diagram. তোমরা কি picture করতে পারতেছো the wave here, right? And when you look at this wave, you'll find that top part usually appears to be darker compared to the rest of the wave here. Okay, each of the top parts that you see here, they're a little darker. And the reason behind that is they come very close together, so the particles actually accumulate and they prevent the light from passing through. So এই জায়গাটা dark মনে হয়। আর যে জায়গাটা নিচে, it also appears different shade. Now, if you remember, we never actually looked at the wave. What did we rather look at? Shadow. উপর থেকে light দেওয়া হতো, the light used to fall on the wave and it used to cast a shadow at the bottom. Can you tell me which one would cast a darker shadow? The crest or the trough? No, both not. Which one will cast a darker shadow? It's a trough. And because it's obviously not that important, but when is a shadow darker? When you're closer to the surface or further away? মানে if further away হলে shadow darker হয়, like what? এই যে এখানে light আছে and I have the surface. This is the surface here. So yeah, that's the shadow here. এটা দূরে আসলে যেভাবে আসলে, is that I know it's bigger, but is that more sharp and prominent or is that more sharp and prominent? The one that's closer to the surface, right? যেখানে surface মানে what I mean is that closer to the bottom. So closer to the bottom থেকে ওই light গুলো are too easily blocked করে, if you see here. আর তোমার যত কাছে আসবে, yes, it becomes more prominent, but what does it become? Yeah, it gets blurred. Okay, so basically the term they use is contrast. Okay, so যত কাছে আসবে, it's more contrasted. Anyways, none of our concern for our AS. All you need to know is it casts a shadow, right? And when you look at this from the top, you'll find that there's a series of lines generated here. And these series of lines that you see here, these are basically what we call wavefront. So what is the definition of a wavefront and what is it actually doing? Like, why does it form a line like this? So that's pretty straightforward, but very important to understand. When the dipper hits the water, right, it disturbs all the water molecules in a line. And all those water molecules will start to do something. What? Oscillate. And as they oscillate, since the dipper hit them all at the same time, they all oscillate together and they all start to move together. And that movement creates an illusion of a water actually passing by, a line. And this is what we call a wavefront. Etar analogy হচ্ছে, think of a parade, a military parade, where you have the army marching and you can see the army march, they're very in sync all the time, right? When they're moving together. So if you look from the side, you might just see one army person, right? But then if you look at an angle, you'll find that there's a line of 10 of them, right? So when you look from one angle, you just see all of them together, right? What do they need to do in order to appear in a line? Yeah, they be in sync with each other. They must perfectly sync their movements. Wouldn't that look like one from the side? Each of the particles are moving together. So they have the same sync with each other. And sync is not the term. Sync মানে SYNC. So we don't use sync anymore. We use a term called in phase. And phase difference chapter 2, we'll learn that better. In phase মানে হচ্ছে they're just doing exactly the same thing as everyone else. So they all appear to move together, and that creates like this artificial line out there. It's an imaginary line. It's essentially trillions of particles just doing the same thing. So they all appear to be what? A single line. Okay, it is called a wavefront. Yeah, you're just going with that thing. So if you look from the top, it looks like a wave. The people who are marching normally. Okay, Acha, so your wave is generated. So I'll go back to your O-level questions, see if you can answer them very quickly. Can anyone tell me what controls the speed of the wave here? Like the speed, speed wave ta jaচ্ছে, এটা কিসের উপর depend করে? Vibration of the motor, frequency of the motor. And what controls the frequency of the motor? Current or power. Acha, okay. So I mean, question number 2 rearrange kori. The dipper going up and down is what we refer as what? Frequency, because how many times your dipper goes up and down represents how many times your wave was generated, right? So if your dipper goes up and down 5 times in a second, what is the frequency? 5 hertz. You understand that, right? And the wave moving forwards is what we refer as velocity. That is what? That is how fast the wave is traveling forwards. So if you see a ripple on an ocean or something, on a pond, a ripple ta koto tatari jacche, that is what? Your velocity. And then there's another quantity here, which is very obvious here. This is your what? Amplitude. So I want you to tell me, how do I control each of them? It's very important, okay? So first of all, what controls frequency? The motor, the dipper, right? What can I call that as a generalized term? Because I'm just having a motor use. So what controls the frequency of your wave? Source, right? Very good. So the frequency depends on the source. Source মানে হচ্ছে where it originated from. So lighted জন্য lighted color, right? Sounded জন্য হচ্ছে vibration of the speaker. For your ripple tank, it's a movement of your dipper, right? So this is basically the source, okay? So the source controls the frequency. Can anyone tell me what controls the amplitude? Huh? More the amplitude, right? Do you understand what he meant? It's basically the displacement of the dipper. So if the dipper goes like this, it's very easy to even notice, right? So this is a dipper, and if I hit the board, it will make a sound, right? So that's the sound, right? I'm gonna make a change. Tell me how does the sound differ, okay? So original data. Next হচ্ছে what's different? Louder. So what changes in my graph? Amplitude and yeah, frequency, right? Frequency is same like your frequency lower. So yeah, I can control both from my source. So lighter do the amplitude বাড়াতে যাও, what do you increase? Brightness. Do you get my point? Brightness money into the height. We have this in our syllabus. I'll be teaching this in detail. How do I change the frequency of a light? Now, power to energy. How do I change the frequency of a light? Very good. Color. Color is what frequency is based on. Remember your violet, indigo, blue. You can have frequency show a different. So frequency depends on the color. So if you want to change color, you need to change frequency or vice versa. If you increase the brightness of your lamp, তখন কি change হয়? Color to change হচ্ছে না, but you're getting more energy. So what change? Amplitude. Okay. Now question: what controls my speed? Frequency and displacement, like amplitude and frequency. Acha, okay. Anyone else? What controls my speed of wave? You know this. That's why it will be disappointing now, partly. No. You guys are going for the equation because there's lambda how to so no. Because again, we learned this in the equation B equals F lambda, right? V and lambda, sorry, V and F, right, are independent variables. মানে হচ্ছে তুমি চেঞ্জ করতে পারবা। ওটার কনসিকোয়েন্সে কে চেঞ্জ হয়? Lambda. So এরকম না যে তুমি ফ্রিকোয়েন্সি চেঞ্জ করলে V চেঞ্জ হবে, রাদার কি চেঞ্জ হবে? Lambda. আবার V চেঞ্জ হলে কে চেঞ্জ হবে না? ফ্রিকোয়েন্সি কে চেঞ্জ হবে? Lambda. So whatever you do just changes the what of the wave. Lambda. Okay. So V কে দিয়ে F control করতে পারবে না, উল্টাটা হবে না। I'll tell you answerটা এটা expect করতাম পারবা। As I speak, right, and then different words are coming out, কি change হচ্ছে? As I speak, like different words, right? Different words কি মানে mean করে different amplitude, like different velocity, like different frequency. Frequency, high pitch, low pitch, right? These are different frequency. So if you're saying frequency controls speed, right? Wouldn't that mean that some of my words will reach you earlier than some other words? If frequency controls speed, the high frequency words will reach you faster, low frequency sounds will reach you slower. Does that happen? No, right? You wouldn't hear the sound coherent sequence. So yes, frequency has nothing to do with the speed of the wave. So what is it actually? Speed take issue depend on it. Sir? Yes, right. So do you remember sound wave? In air, sound was 333 meter per second. In water, it was 1500, right? What changed in both the places? It's the medium. Okay, so medium controls it. Ripple tank arta chilo, it amne lagbe na, thankfully. Depth. When it's a depth change, so yeah, velocity depends on the medium through which it's traveling through. In what medium is light the fastest? Vacuum, right? In what medium is the sound the fastest? Solid. So sound is a little odd. Sound is based on vibrations of mechanical nature. So more particles make it easier to travel through. Okay. Light is vibration of not mechanical nature. It's a field, electromagnetic wave bola hoy. What does it prefer? Freedom, like, nothing in its path. So that's why vacuum is like the best. Right. Anyways, right. Amplitude ki should depend kore thole the vertical displacement of your yeah. So this is it. It কিছু add করে দিচ্ছি. I would prefer it at the moment কিছু না copy করা because it was just a recap of your O levels, okay? Candela has been extinct since 2017. Yes, it was removed from physics. No, entirety of physics. Why? They found that it's not useful. It's what it is. I mean, there are a lot of quantities that have been revamped. Candela was removed. So we didn't learn Candela. Candela can convert to watt per meter square. Base quantity, right? It was just one quantity needed for this one thing. There was no need for it. So if they ask us for the SA units of Candela, no, I'm to correct some Candela correct. All also correct. Okay, anyways, I just added whatever I've mentioned. So আশা করি তোমরা পরে দেখে বুঝে যাবে আচ্ছা I need to move on to other things. So let's go to page number 29. So 29 is our two. So transverse wave, longitudinal waves, এগুলার হচ্ছে ideas আমাদের দেখতে হবে. Can anyone tell me what's a transverse wave? Parlay, I'll just skip this. Okay, so like very basic. O-level definition exactly. So what's a transverse wave? Right. So Maniki, the particles is just going up and down, which way is the energy moving? Forwards, right? And what's the longitudinal wave? Yeah, the particles are moving back and forth and the energy is still going forward. So the movement is parallel in one and one is perpendicular. It can be a complicated question. Yes. Okay, so I'll show you a couple of them. But definition to so just to acknowledge what they are coming in. Okay, so that these are the two definitions out there. Also, hopefully there are three different types of wave provided here. You see a pulse, continuous, and train. এগুলা হচ্ছে different types of waves out there. I'll explain what they do. এটা একটু draw করে নিতে পারবো। So আমি soundগুলো শুনাই তোমাদেরকে। What's a pulse, what's a train, what's continuous, okay? Wait, I'm gonna play a song, don't worry. আচ্ছা একটু শুনো এদিকে সাউন্ডটা শুনো, okay? So what's continuous, what's train, and what's pulse? That you heard was a train. It was multiple waves together, okay? I'll play a pulse right now. do you hear these pulses, right? Mane choto choto intervals ashe, right? And so again, train, right? So it started, it stopped. You can see the start, you can see the stop, right? These are all pulses. Okay, these are individual waves, single oscillation. And so একটা হচ্ছে pulse, একটা হচ্ছে train, continuous তো হচ্ছে এটা। So ধরো এই মোমেন্টে somebody entered the room and then left the room. Would that person know what happened? Because সে যখন room enter করছে, wasn't the sound already there? The room leave করলো, wasn't the sound still going on? So for that person who can't see the start and the end, what is the sound? Continuous, right? It is a train eventually, because the sound is সারা জীবন চলবে না. So eventually most waves are trains, okay? Which waves we feel are continuous? Normally light from space. We don't know when it started. If they're going by us, we don't know they will stop. Okay, so that's almost the closest to what a continuous wave would be. Our train হচ্ছে short burst আসতে পারে, so train এটাও হতে পারে। Do you see the difference? They can into their longer in duration. Longer duration মানে অনেকগুলো wave generate হচ্ছে। Okay, so কেন এটা করতে হয় আর কিছু সময় তোমাদেরকে? No, pulse is one single wave from like one single wave generation. So one cycle. What's the difference between continuous and train? Continuous হচ্ছে no start, no end. Our train টা হচ্ছে there's a start, there's an end. Yeah. Done, সবাই? Once again, বলে রাখি, our target is to wrap up entirety of waves by December, if not at least like 90% of it. There's this topic called diffraction rating, which maybe to time লাগতে পারে, and January they will do electricity and particle physics. Okay, so that's it. Particle physics একটা chapter is over there. It's আগে বলে রাখলাম শুরুতে, it's smaller than like it takes 3 classes. It's basically alpha, beta, gamma. There was a table I taught in your O levels. We table that same. I think there are fewer things there. And there's this thing called standard model particles: quarks, leptons, mesons, baryons. That's it. There are tables that we will learn. So what a big timeline. Yeah, they're like what you get when you break down a proton, a neutron. Yep. It really added. আগে যেটা ছিল particles that took like one class. এখন ওটা that but they class extra লাগে। No, you guys had 3 chapters. ওগুলো তো পাওয়া electric fields। তারপর হচ্ছে there's a chapter based on particle structure, crystalline structure, abnormal structure. মানে ফালতু chapter ছিল। Yeah, I mean it was only this application of on stuff. Right, done. Okay, so let's move on. What we're gonna do is so page 30 I'll be showing you that what you can expect from this topic. Microwave oven. microwave oven ভিতরে you put a bar of chocolate and it tells you what it like this. Yeah, that's what they do. I mean, that's what you can do in a lab. Actually, our own কিছু আছে, they use lasers and then they're reflected পানি খায়। No, there must be before that. Those are done through math and practical based. তখন তো যারা papers, so there was no practical examples of it. If you want to do it, you can use your microwave in your home. Well, ওটা এই নতুন সিলেবাসে লেখা নাই, but it's I did it. I did it just for safety of it, but new syllabus mentioned. You'll find plenty of it in past paper. All right, so it's screen it. So যেটা করবো এখন, I'll be showing you transverse wave and longitudinal wave এর হচ্ছে কি টাইপের কোয়েশ্চেন আছে। This definition to grade 7 থেকে অনেকে জানো, but what's it doing in your A's syllabus? ওটা দেখো। Okay, shall I screen it? Let me explain the question here. So you have a transverse wave, which is moving this side. Okay, so this arrow that I've drawn here represents the direction of what? Yeah, transfer of energy or wave propagation. Wave movement is a wrong term. Okay, wave movement মানে হচ্ছে ধরো আমার যদি এটা হচ্ছে my wave হয়, wave movement মানে this thing will just move forward. Okay, but wave propagation মানে হচ্ছে it'll grow forwards. মানে এটা এখানেই থাকবে and it'll be like growing outwards. Imagine when I turn on the light, ওইখান থেকে wave বের হলো না? Doesn't the wave like grow all the way till the table? নাকি এরকম হয় যে একটা pulse create a pulse আমার কাছে আছে, ওরকম হয় না তো? It grows, that's the term, propagates forwards. Okay, there are some places they allow motion movement, right? But the right term is propagation. Propagation of wave, and wave carries what forwards? Energy, right? So this is your direction of wave. Direction of wave. And on this particular wave, there are some particles placed. So particles, if you're having tough time to understand what's going on here, imagine this is water. A water conical ball rakha. It'll flow for this. Okay, so that's what I'm going to show you right now. So you have these particles or spheres placed here. Sphere gulo teen jagay rakha, like na aro beshi dete hobe, this and that. Okay, so these are the particles on the wave. I think at the start of the chapter I showed you like a demonstration with a wrench and some beads. Mone ache ekhane red color ekta bead chilo jeta upor niche jay, right? Oh, so imagine these are beads on a rope. Is that okay? Mane ekta rope er moddhe I put some beads out there and now moving the rope up and down. Beads gulo ki korbe? Move korbe. So my question for you, number one question, do the beads move forwards or backwards, upwards or downwards? Yeah, it's just up and down. There's nothing moving forwards. Be very careful about this. Transverse wave, there's nothing in material sense moving forwards. There's only one thing moving forwards. What is it? Energy. Okay, it's a way of transferring energy. Clear about that? Acha, এখন what you need to tell me is this wave moves slightly forward. Okay, draw arrows to show which way will the particles be moving in the next instant. Next instant মানে কি? এই যে আমি draw করি এখানে. This is your wave. Wave-টা এরকম করে সামনে চলে যাবে না? Like, you know, it's actually going forwards, right? As the wave travels forwards, which way are the particles moving? That's the question. Okay, so we'll start with A, B. I'm gonna try for just C, D, E, and F. So you need to tell me which way are the particles moving. I'll start with A. Okay, so the wave, the particle has reached the peak of your wave when it's at the top. Where can it only go next? Down, right? It can't go any further up. It wouldn't go forward. It wouldn't go backward, right? So the particle A motion at the next instant, right away, is downwards. Okay. Which way is B moving? Okay. How many of you think B is moving upwards? B is moving upwards. Can you explain?